Hi, my name is Kate Berry from the University of Texas at Austin, and welcome to this video on change problems, which are one of the schemas that are featured in our Pirate Math Equation Quest multi-step word problem intervention with total difference, change, and equal group schemas. Here we have 5 intervention components: captain cards, equation quest, Buccaneer problems, ship shape sorting, and our Jolly Roger review. Change problems are featured during Buccaneer problems, ship shape sorting, and our Jolly Roger review, but primarily during our Buccaneer problems, which is our guided practice activity. Because change problems are primarily featured in Buccaneer problems, this video is going to focus on change problems within Buccaneer problems. So let's take a look at our materials. First, we will need our large schema mat version 3. We have version 3 because this is when we introduce change problems, but we've already introduced total and difference problems. We also have our Buccaneer problem worksheet, a pencil, and our What Do You Ask Yourself poster, which will help students question and gesture. So here again we have 4 schemas in our multi-step word problem intervention that are focused on single-step word problems: total, difference, change, and equal groups. This video is focused on our third additive schema, or our change schema. As we work through our word problems, we always embed gestures. We want to encourage students to question and gesture. We find it helps them differentiate among the 4 schemas. So for change problems, our change gesture looks like this. Do we have a starting amount that increases or decreases to a new amount? So we put our hand right here, and then we move it up to indicate an increase, and we move it down to show a decrease. So it looks like this. Do we have a starting amount that increases or decreases to a new amount? When we work with students and we introduce change problems, we indicate or introduce 4 different types of change problems. We have problems where our end amount is missing, where our starting amount is missing, where our change amount is missing, and we also feature problems where we have 2 or more changes. Now I'm going to model how to set up and solve all these different variations of change problems, but before I do that, I want to take a second to make sure that we understand the difference between change increase and change decrease. So let's take a look first at our change poster. So here we have all the different steps that students go through to set up and solve a change problem. Our first step is to write our change equation, which is ST plus or minus C equals E. This stands for the start amount plus the change amount if we have an increase, or minus the change amount if we have a decrease, equals or is the same as the end amount. After students write the change equation, they find the starting amount, the change amount, and the end amount. And then they write our signs, a plus and same as or equal sign if we have a change increase problem, and a minus and same as sign if we have a change decrease problem. Then we're going to solve for blank, and then we're going to make sure that our answer makes sense, and we have this little parrot here that's going to remind us to check for reasonableness. So let's take a look at this change problem. It says Susan had $5 in her piggy bank. Then she earned $7 for babysitting. How much money does Susan have now? So here we have a starting amount. She had $5 in her piggy bank, but then something happened. There was a change. She earned $7. So because we have a starting amount that's increasing, this is going to be an example of a change increase problem. Now let's look at a change decrease problem so we understand the difference. But here you can see we've written the change increase equation. The start amount plus the change equals the end amount. So here this says there were 9 oranges on a tree. Then 5 oranges fell off. How many oranges are on the tree now? So we had 9 oranges and then something happened. What happened? 5 fell off. So when 5 fell off, our amount is decreasing. So this is an example of a change decrease problem. And the equation that goes with the change decrease, very similar to our change increase, except for our sign is a minus. So we have the start amount minus the change amount equals our end amount. So now I told you we were going to set up and solve the 4 different versions of change problems that are featured in our multi-step word problem intervention. Let's get started by practicing a change problem where our end amount is missing. So the first thing we want to do whenever we see a word problem is check for a table or a graph. I don't see a table or a graph, but if I did, I would number it. But I don't, so I'm gonna go ahead and write my UPS attack strategy letters in our corner here, and I'm gonna go ahead and get started. Our first U, it's hidden a little bit above the problem, but you can see it. It says understand by reading. So let's read our problem. Sebastian went bowling with his friends. During the first game, he earned 75 points. Then he earned 128 more points in the second game. How many points has Sebastian earned now? I feel like I understood the problem. I'm gonna check off that first U. My second U stands for underline my label. I can mostly find my label in our question sentence, which says how many points has Sebastian earned now? Well, they're asking me about points, so I'm gonna go ahead and underline points, check off my second U. Now I can move to my first P, which stands for put parentheses around needed numbers. So what I need to do is scan all my numbers and make sure they're talking about or related to our label, which is points. So I'm gonna scan, my first number is 75, well that's about points. So I know I need that, so I'm gonna put parentheses around 75 points. My next number is 128, it says 128 more points. So I know I need that. I'm gonna put parentheses around that. I've completed my first P. My second P stands for put numbers in order. Now here we're dealing with single step problems, so we only need to put a 1 above our needed numbers. But when we're working with multi-step problems, we have to put a 2 and even a 3 above those numbers. But here I know I have 2 numbers, so this is probably gonna be a single step problem. So I'm gonna put a 1 above those numbers. Now I'm going to move to my first S, which stands for schemas. This is when we really want to incorporate those gestures and move to our what do you ask yourself poster. So I can say to myself, our parts put together for a total, our 2 amounts compared for a difference, do we have a starting amount that increases or decreases to a new amount, or do we have groups with an equal number in each group? Well, here, Sebastian went bowling and he earned 75 points. But then something happened. There was a change. He earned more points. So because we have a starting amount that increases, I know this is a change problem. So I'm going to put a plus C. A lot of our kiddos, if you do a C plus, they think that's the grade. So we want to stay away from that. I know this is a single step problem. So I'm going to put a 1 right here and a dash and a plus C. That is going to remind me that I have a single step problem that's a change increase. So I've checked off the S. I know this is a single step change problem, so I can go to my large schema map version 3, go to my change poster and just follow my steps. We said this was a change increase problem, so I'm going to need my change increase equation, which is ST plus C equals E. This stands for the start amount plus the change amount, because he earned more points, equals our end amount. Now our next step stands for find the start amount, find ST. I know he started with 75 points. I'm going to check off that number. I always like to check off the numbers after I use them. The next number is the change. Well, the change that happened was that he earned more points. And I know he earned 128 more points, so I'm going to check that off here. I don't know my end amount. That's what we're looking for. So I'm going to go ahead and put a blank and I'm going to add my signs. Now here we always want students, if we have greater numbers like this, we want them to line it up. It's a little bit squeaky here, but it's making it a little more entertaining for you guys. So here we can start in our ones column. Notice I've drawn lines to separate my place values and I'm circling our sign. 8 plus 5 is 13. I'm going to regroup. 7 plus 2 is 9, plus that 1 is 10. So I have 203, but I'm not finished. We have our number answer, but the number answer always needs a buddy or else it's going to get lonely. I know my label is points because that's what I underline. So that's what I'm going to write down here, points. I'm going to check off that S. Now the very last thing we need to do is check for reasonableness. I need to make sure my number answer makes sense and my label answer makes sense. So here we could subtract, or we could subtract 203 minus 75 or 203 minus 128 to make sure that we would get 75. Or we could just talk about it. If we have 75 and we added 128, it does make sense that we're dealing with whole numbers, that 203 would be the correct sum. And my label answer points, that matches what I underline. So we are good to go. Really wonderful job solving this change problem with a missing end amount. So before we take a look at another example, here's an example of student work where the student solved for the missing end amount. They used X. You can use blank, but you can see here it says last year there were 11 trumpet players in the band. This year, 14 new trumpet players. And it says some tuba players joined the band. How many trumpet players are in the band now? Here the student crossed off or crossed out the irrelevant information and set up and solved for a missing variable and wrote 25 trumpet players. And here they have the C plus or plus C in the corner to let me know it's a change increase problem. Let's take a look now at an example of a change problem where our starting amount is missing. So as always, we want to check for a table or a graph. I don't see one, but if I did see one, I would number it. So what I'm going to do is write my UPS check attack strategy, UUPPSS check in our corner over here. My first U stands for understand by reading. This says Melissa brought money to spend at the yard sale. She bought a book for $4. The cashier gave her $11 in change. How much money did Melissa bring to the yard sale? So we've read our problem. I feel like I understand it. Now I'm going to move to my second U, which is underline our label. Our label typically can be found in our question sentence, so I'm going to read that. It says, how much money did Melissa bring to the yard sale? Here they're asking me about money, so I'm going to go ahead and underline money. We don't want kids saying 5 money or 4 money. We need to figure out how we're measuring or talking about money. I see that there are dollar signs next to my numbers, so that's going to help me understand that we have a dollar sign. So I'm going to put the dollar sign below the money that we've underlined. Check off my second U. My first P stands for put parentheses around needed numbers. So I'm going to scan my numbers and make sure they're all talking about or related to our label, which is money. So my first number is 4. I kind of like to put parentheses around what the 4 is talking about, and that's talking about a book. My next number is 11. We got $11 in change. So I've put parentheses around my needed numbers. Now I need to put my numbers in order. Here we have 2 numbers. We know we're dealing with a single step problem. So I'm just going to put a 1 above my numbers, or what I put in parentheses here. Now when we're dealing with 2 and even 3-step problems, we have to think more carefully about where we put a 2 and a 3 above which numbers we do that. But here we're just dealing with single step problems, so we can just put a 1 above those numbers. So I'm going to check off my second P. My first S stands for schemas. Here we want to question and gesture and think about what the problem is asking us. We say our parts put together for a total, are 2 amounts compared for a difference, is there a starting amount that increases or decreases to a new amount, or do we have groups with an equal number in each group? So here I know Melissa brought money and then she bought a book. So she brought money and then something happened. What happened was she bought a book. So we have a starting amount, which is the money that she brought to the sale, but her amount decreased when she bought a book. So I'm going to put a 1 to help me remember it's a single step problem. And I'm going to put a C minus, or you can put a minus C, and I'm going to circle it. I know this is a change decrease because my amount decreased, or Melissa's amount decreased when she bought the book. I'm going to check off my first S, and now I can look at my large schema mat version 3 and write my change steps. So here I know that this is a minus or a decrease, so I'm going to write ST minus C equals E, or the start amount minus the change amount equals the end amount. Now I'm going to look for my start amount. Here it says Melissa brought money to spend at the yard sale. I don't know how much money she brought to the yard sale. She could have brought $50, $100. We don't know. So our start amount is actually our missing information. She brought some money, and then there was a change that happened. She bought a book. So I'm going to put a 4 under my change amount and check that off. And then she had $11 in change. That was what she ended up with. So that's my end amount. So I'm going to check that off. And I'm going to add my signs. Now I need to figure out our missing starting amount. Now when we have a change decrease problem and we're subtracting here, our missing starting amount is going to be the greater number. So if our missing starting amount is greater, we're actually going to need to add these 2 numbers, because if we subtracted these 2 numbers, that wouldn't make sense for our starting amount, because our starting amount is going to be greater than our change and end amount. So here I can do 11 plus 4. I can do that in my head. That's going to give me 15. So I have my number answer. Now I need my label answer. Well, I put a $sign here, so I can do $15. Or if students want to write out $15, hopefully their markers are a little bit less squeakier than mine. If they want to write out $15 or have the $sign, they can do either one of those examples. So now we've solved. Our very last thing is to check for reasonableness. We need to make sure it makes sense. So we can talk through it or do the math again. I'm going to talk through it. So here I had $15. I bought a book for $4, so my amount decreased, so it does make sense that I would have $11 remaining. And lastly, we need to check our label. Our label is dollars or the $sign, and that matches what we underline in our question sentence. Nice job solving this change problem with a missing starting amount. So here's a student work example where we can see where we have a change problem where our starting amount is missing. So here the student, you can see it's a change increase problem. They have X, you can have blank like we do in our problem, but you can see here we've set up and solved for our missing variable. So this is just an example of student work with our missing change amount. Let's take a look at our third type of change problem that's featured in our multi-step word problem intervention. These are change problems where our change amount is missing. So here we're first going to check for a table or a graph. We don't see one. If we did, we would number it. But we're going to write our U, P, P, S, check, attack strategy on the side. And I'm going to get started with my first U, which stands for understand by reading. So let's read our problem. It says there were 56 children at the park. In the afternoon, more children came to the park. Now there are 156 children. How many children came to the park in the afternoon? A lot of children at the park today. We're going to check off that first U. Our second U says underline the label. We're going to find our label most of the time in the question sentence. It says how many children came to the park in the afternoon? Well, they're asking us about children. Woo, squeaky. So I'm going to go ahead and underline children. I checked off my second U. I've underlined the label. I can move to my first P, which stands for put parentheses around needed numbers. So what I'm going to do is scan all of my numbers and make sure they're talking about or related to children. My first number is 56. Well, that's about children, so I'm going to put that in parentheses. I'm going to keep scanning. My next number is 156. That's also about children, so I'm going to check that off. We put our numbers in parentheses. Now our second P stands for put numbers in order. With single step problems, it's pretty easy here. We can just put a 1 above our needed numbers. Here we only have 2 numbers, so I'm pretty sure we're going to have a single step problem. Now when we're introducing multi-step problems, we have to think a little bit harder about what's happening because we have to think about where we're going to put our 1s, our 2s, and sometimes our 3s. But here we just have our 1s above our needed numbers. I'm going to make that a little bit larger. And now we can move to our S, which stands for schemas. So here I'm going to go to my What Do You Ask Yourself poster and ask these questions. Are parts put together for a total? Are 2 amounts compared for a difference? Do we have a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? Well, let's look at our problem. It says there were 56 children at the park. In the afternoon, more children came to the park. Now there are 156 children. How many children came to the park in the afternoon? So here we had 56 children, and then there was a change. The change is that more children came to the park. So I know I don't not only have a change problem, but I have a change increase because we had a starting amount, which is the 56 children, and then the change, which was that more children came to the park. So I'm going to put a 1 because it's a single step problem, and I'm going to put a plus C, or you can do a C plus. And I'm going to circle it to help me remember that it is a single step change increase problem. Now that I know my schema, I can move to my second S, which stands for solve, and I can direct myself to my large schema map version 3 with our change poster. So here I'm going to write my equation. I know I'm going to write the change increase equation because I know this is a change increase problem. So I have the starting amount plus the change amount equals the end amount. Now we can follow the next step, find ST. I know my starting amount was 56 because it said there were 56 children at the park. Then it says in the afternoon more children came to the park. More? I don't know how many more we're talking about. It could be 1,000, it could be 200, it could be 5, we don't know. So because it just says more children, that's an indication that we don't know the change. We don't know the number of children who came to the park. Then it says there were 156 children, and that's the end. That's how many children were at the end after the other children came to the park. So we had 56 children. We don't know how many came to the park, but we know there were 156 at the end. Now here, I'm going to add my signs, which are plus and equals, or plus and same as, because we know we are dealing with a change increase problem. Now we could do the math here, but I can do the math in my head because this is pretty easy. 56 plus what gives me 156? Well, I know that that's 100. So I can actually go ahead and write that. Here, if you wanted to, your students could subtract to find our missing change amount. Because if we added these two numbers, it wouldn't make sense for our change amount to be greater than our sum because we're dealing with whole numbers. But here I know the mental math. 56 plus 100 plus 100 equals 156. But I'm not finished. My number answer, I need my label. All I need to do is look at my question sentence. I underline children. I have my number answer and my label answer. Very last thing, we have to check for reasonableness. Okay, if I have 56 children and 100 more come to the park, it makes sense that I'm going to have 156 children. You also could have kids do the math again to check their answer. But I know my number answer makes sense. My label answer, children, well, that matches what I underline in my question sentence. Great job solving this change problem with our missing change amount. So we just solved a change problem with a missing change amount. Here's an example of student work where the student is setting up and solving for the missing change. So you can see students are setting up and solving many different variations of change problems. So let's take a look at our final example where we have change problems with 2 or more changes, and these are my favorites. So let's take a look at a problem that shows 2 or more changes. First, I'm going to check for a table or a graph. I don't see a table or a graph, but if I did, I would number it. But I'm going to go ahead and write our UPS check squared attack strategy on our side right here. Our first U stands for understand by reading. This says Jessica earned $11.50 for painting a fence. She spent $7.50 on earrings. Her mother gave her $11.75 for her birthday. How much money does Jessica have now? I feel like I understood the problem. I'm going to check off my first U. My second U is underline the label. I'm going to check my question sentence. It says, how much money does Jessica have now? I know they're asking me about money, so I'm going to go ahead and underline that. And I'm going to put a dollar sign because we don't want to write an answer as 5 money or 10 money. We will say $5. I know it's dollars because I can look and see dollar signs in front of all my numbers. My first P stands for put our numbers in order. So I'm going to scan all of our numbers and make sure they're talking about or related to dollars. So my first number is $11.50. That's about money. And I like to go all the way to the end so I know what we're talking about. We have $11.50 for painting a fence. My next number, also about money, so I'm going to need that, $7.50 on earrings. My last number, also about money, $11.75 for her birthday. So here I'm going to check off my first P. Now here we have a problem where there's a lot going on. We have more than one change, but it's still just the change schema. It's just featuring change problems. So even though we might be doing a couple of different operations, here it actually is a single step problem. We're going to talk about the increases and the decreases in just a second, but first I'm going to put a 1 above all of my needed numbers. Here we know all of these numbers are talking about money, and we need all of these numbers to solve our problem. But again, because we're only featuring one schema, we're only going to put a 1 above these numbers. Now I can move to my first S, which stands for schemas. So I'm going to move to my what do you ask yourself poster. So let's ask these questions to figure out what the problem is talking about. It says, are parts put together for a total? Are 2 amounts compared for a difference? Is there a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? So let's kind of break our question in our word problem up into parts to help us out. It says she earned $11.50 for painting a fence, okay? So that's what she started with. And then she spent $7.50 on earrings. So I had an amount and then something happened. What happened? Well, she spent the money. So if she spends money, her amount is going to be decreasing. But then something else happened. Her mother gave her money for her birthday. So this is a change problem, but we have multiple changes. So Jessica had some money that she earned for painting a fence, but then something happened. She spent some money, so her amount decreased, but then she increased when her mother gave her money for her birthday. So what I'm gonna do to identify this is a double change problem, or a change problem with two changes. Put a 1 to identify this as a single step problem. I'm gonna put a C minus, because the first change was that she decreased because she spent money on earrings. Then I'm gonna put another C and I'm gonna put a plus because she decreased, but then she increased again. Whoop. Squeaky marker. But then she increased again when her mother gave her money for her birthday. So this looks like, okay, this is kind of confusing. We have multiple C's. That's okay. All we need to do is update our change equation. So I'm going to write ST, which is my start amount, minus C, because my first change was a decrease when she spent money on earrings, plus C, because my second change was an increase when her mother gave her money for her birthday, equals the end amount. So all we're doing when we have change problems with more than one change is just altering our change equation. So we have the starting amount minus the change amount plus the change amount equals the end amount. Now I think these are really fun to solve. So we can check off our first S, we've identified the schema, and now that we've written our equation, we can go through our steps. I know my starting amount is $11.50 because that's what she earned for painting the fence. Then she spent $7.50 on earrings. So I'm gonna put that under our first change. And then her mother gave her $11.75 for her birthday, so that's our second change. And I don't know my end amount. We want to know how much money we have now. That's what we're looking for, so that's gonna be a blank. Now we need to just be very careful when we write our signs. We're gonna have a minus and then a plus. So now we're ready to do the math. I'm gonna always go left to right, 1150 minus 750. I could line that up, but I also know that if I do 1150 minus 750, it's gonna give me $4. So I'm gonna actually put my decimal and my 2 zeros for place value here. And then I'm going to add the $11.75 from her mother for her birthday. So we're going to draw our lines and circle our signs. This marker is a little squeaky. But here I have $15.75. Now I'm not finished. I need to look at my label. Here I have the dollar sign. If your students wanted to write $15.75 here, or they could write dollars next to it, but I'm going to put the dollar sign here. Now I've solved the problem. Now when we're checking for reasonableness, when we have a change problem with 2 or more changes, we really just want to talk through it. So here we have $11.50. If I spent $7.50, it would make sense that I would have $4. And then if I also received $11.75 from my mom, then it would make sense that our end amount was $15.75. So I know my number answer makes sense, and my label, well, that matches what we underlined. So it wasn't that hard after all to solve a change problem with multiple changes. Nice work. So here is an example of a student solving a change problem with multiple changes. Here you can see something similar to what I just did, the start amount minus the change amount plus the change amount equals the end amount. And you can see here we have the C minus and plus, and the student solved for the missing information, solving the problem left to right. Thank you so much for taking the time to view this change schema video, which is one of our schemas featured in our multi-step word problem intervention. I would like to take a minute to thank the Institute of Education Sciences, the University of Texas at Austin, and the Meadows Center for Preventing Educational Risk. Without their support, this work would not be possible. I look forward to seeing you in another video.